Welcome to this tutorial on building a 3D cooperative game using Java. In this series, we will break down the process into manageable steps, walking you through everything from setting up your environment to creating multiplayer mechanics. Make sure to have your Java development kit installed and your favorite IDE ready. To begin, let's set up our development environment. We will use a popular game engine for Java called libgdx, which allows us to develop games for multiple platforms. Head over to the libgdx website and follow the setup instructions for your operating system. Once your libgdx project is created, let's explore the basic directory structure. Open your project in your IDE. You will notice several important folders: Core, Desktop, Android, and iOS. We will primarily work within the Core folder as it holds most of our game logic. Next, we'll create the main game class. This is the entry point for our application. Let's create a new Java class called GameMain under the core/src/your package directory. In the code above, we create a sprite batch which will help us manage our 2D rendering. We set the initial screen to main menu screen, which we will implement shortly. The render method calls the render method of the current screen, and dispose ensures we free up resources. Now, let's implement the main menu screen class. Create a new class named main menu screen in the same your package directory. In this class, we load a background image for our menu. The render method clears the screen and draws the background image. Don't forget to place your main_menu background.png image in the core/assets directory. Now, let's create a basic player class to represent our cooperative player in the game. We'll create a player class that manages the player's position and behavior. In the player class, we utilize a sprite to represent the player visually. We have methods for updating the player's position based on input and for drawing the player on the screen. Now we need to implement the game world. For our cooperative game, we'll create a game world class that manages all the game entities, including players and obstacles. Let's create the game world class now. In the game world class, we maintain a list of player instances. The initialize players method loads the texture for each player and adds them to our list. The update and draw methods ensure that all players in our game are updated and rendered correctly. Next, we will modify our main menu screen to allow players to start the game. We can create a simple button that, when clicked, will transition the user to a new game screen. In the code above, we check for mouse clicks. If the left mouse button is clicked, the game transitions to the game screen class. We'll create this class next, where the gameplay will actually take place. Let's implement the game screen class. This screen will manage our game loop, including updating game logic and rendering objects on the screen. In the game screen class, we create our game world instance where the main game logic occurs. The render method clears the screen, updates the game world, and renders all game entities on the screen using the sprite batch. To add cooperative gameplay mechanics, we need to handle input from multiple players. In a local multiplayer setup, we can allow multiple players to control characters using different keys. In the code above, we check for key presses and move the player accordingly. You will need to index into your players list for additional players. This is how you can create a simple local co-op mechanic. To keep track of multiple players, you may want to add initialization for additional players in the game world class, setting different control keys for each. Now let's add some obstacles or collectibles in the game world. For simplicity, let's create a collectible class that players can collect. The collectible will disappear when a player intersects with it. In the collectible class, we create a sprite for the collectible. You can add collision detection logic later to determine if a player collects it. Next, let's create a mechanism to check if players collide with collectibles. We will implement collision detection in our game world class. This is crucial for cooperative gameplay. To check collisions between players and collectibles, you will use bounding box checks or distance calculations between the player and collectible sprites. If they intersect, you can remove the collectible from the game. Now that we have our basic game setup, let's work on multiplayer networking. For a simple, local multiplayer experience, we can set up 2 players on the keyboard. However, for online multiplayer, you would typically use something like Java sockets or a higher-level library like Cryonet. In this pseudocode, we create a server that binds to specific ports. You would need to handle connections, player state synchronization, and send the necessary game state over the network. As we approach the end of this tutorial, let's add some finishing touches, such as sound effects and music. libgdx makes it easy to integrate audio into your game. To use this audio code, make sure to place your audio files in the Assets directory. Triggers for playing the sound can be placed in various game events, like player actions or collectible pickups. Finally, let's add a pause feature and screen transition effects to improve the player experience. Utilizing the existing screens can help maintain a smooth flow in gameplay. Congratulations! You have learned how to build a simple 3D cooperative game in Java using libgdx. Remember, game development is an iterative process, so don't hesitate to revisit your code to improve and add features. In the next series, we will discuss more advanced topics like AI for enemies and level design.